Hey everyone, and welcome to another awesome episode of the Surviving Mold podcast, where illness is defeated and lives are restored. And here to explain why genomics are so important for understanding your physiology is Dr. Jimmy Ryan. Doctor, welcome to the show. You've been helping a lot of people with this Progene DX system.
Well, what we're finding is that there is a suppression of basic metabolic functions in cells, or I shouldn't say there's a suppression of metabolic functions. I can say there is a suppression of genes that control basic metabolic functions. So when we talked, we were trying to think of a good way in explaining how a cell functions, and maybe a city is a good example, but there are elements of the cell that have very basic functions. There's what's called a ribosome. And a ribosome is the place where a copy of the gene comes to be made into a protein. And nothing can survive without protein. That's just a basic element of life. So when a protein is made, there's a process that is very sensitive to biotoxins. So when we look at the toxins that mold make, mycotoxins, a lot of them target this ribosome, which is a basic element needed for life, because a microbe might not necessarily have one specific enemy that it needs to compete with. So because these ribosomes are so basic and so critical for life, it's a very good target for an organism who might not know what could be attacking it or preying on it or what it needs to help compete. It knows that everything alive has a ribosome, and if I have a toxin that targets the ribosome, I can almost protect myself from anything. So there is a
very interesting
ultra-conserved piece on the ribosome, and this is called the CIRS loop, if you really want to get into the technical aspects.
There's going to be a primer of definitions for the show if you guys need it. So
this is an element. It's a element of the genes in almost all species that is highly conserved because it's responsible for joining amino acids together to make a protein. So it's highly conserved throughout all species on the planet. And if a toxin targets this highly conserved element, it can basically disable anything that's living.
Wow.
So it doesn't matter if a bug is trying to eat the fungus, or if the fungus needs to outcompete some other microbe. All it needs to do is to produce this toxin, and it can disable basically anything that's living.
Wow.
So
we are waging a war on a cellular level, and we could be losing without even knowing it.
Oh, absolutely. But mold has been around longer than we have, and we've adapted, and we have mechanisms that try to counteract everything that's alive has mechanisms to defend itself from everything else. We have ways to clear toxins, so it's not as dramatic as it seems, unless you have a level of exposure that your body can't cope with.
So would these labs help us understand how to wage these micro wars in our body to better overcome mold illness? Because when we were talking, you were saying that, well, here's how I understand it. If we're looking at the city and we have systems of systems, and for example, the power plant has no energy, the protein, then how are we going to create that energy for someone sitting in their living room that can no longer watch their TV or listen to a podcast or any of that? They're going to be sitting in the dark pretty unhappy.
Right. Well, the first thing we have to do is to be able to understand what the problem is. And this is where the transcriptomic test that we do is really important, because it looks at all the systems in the city. It's not looking at one thing. It's looking at an aerial map of the entire city, and it's looking at everything, and we can actually see what systems are having trouble. Now, that is of limited value if you really don't know how to fix the system.
Yeah.
But at least you can determine where the problem is coming from. So
You know which knob is the control knob that you need to be looking at.
Right. You know which one is not performing correctly. Because, like I mentioned, we have a lot of genes.
50,000, is that right?
Roughly. You know, there's 20,000 protein coding genes and roughly 30,000 non-coding genes. So, kind of a technical jargon there, but
no, it's okay.
So we're looking at all of those, but what makes different cells unique is the genes that they express. So you have one genome, but you have thousands of different types of cells.
Wow.
All of those cells, they have different genes that are expressed from that one single genome that is in every cell of your body. So the different cells that are expressed actually give each different cell its own characteristic. So we have cells in our eyes that are totally different from cells in our feet. You know, we have muscle cells, we have liver cells, we have blood cells, we have neurons. You know,
the list goes on and
the
on.
list goes on and on.
Woo! It's got to be a long list.
So that goes back to maybe in a hierarchy. If we go back to the guitar, that guitar, we could say, if we're looking at let's say a muscle cell versus a white blood cell, we could say, well, the first hierarchy is that guitar is tuned to this key. It's set. It's going to produce these genes where another cell has set, I'm only going to produce these genes. So each cell in your body probably only expresses about half the genes in the genome. It just decides, you know, the genome is a big menu of 50,000 things. And you're going to say, I want this and this and this and this and this, but I don't want these other things. It's like a store. You can go to, I don't know, Home Depot, and they have certain things in Home Depot. And then you can go to a grocery store, and they're going to have totally different things. They're both stores in the body. They're both cells, and they still have the same somewhat basic, principles of operation. They're open from these hours. It's in a building. It's got lights in the building. There's certain things that are the same between all cells, but in the end, each cell has a different inventory.
Wow.
But it all comes from the same genome. It just selects what it needs to function. So your liver says, my job is to detoxify
the body.
Foreign things.
Yeah.
I need these things from the genome, and it produces those proteins. A neuron says, my job is to transmit electrical impulses, and so I need these genes from the genome.
So is the neuron like the communicator?
The neuron is the communicator.
It's like the internet.
It's like the internet, yeah. Communicates. Well, all cells have electrical properties. They all operate on an electrochemical basis. But neurons actually transmit information throughout the body.
Wow. Wow, this is really deep. But what I like about all this is that even though it's so deep, it's so critical to understand, because you could be caught in a problem that you truly don't understand. You could be fighting an illness that you don't have. You could be going from doctor to doctor to doctor while you're trying to figure out all these different symptoms and have no understanding whatsoever what's going on, spending a lot of money, when at the end of the day, you could just find out the data. And I had this kind of theme last year where I said I'm only going to make decisions based off of data, database decisions. I'm even thinking about getting the license plate DBD. But here's the thing, with genomics, we now have that data. But what a lot of people fail to understand, and especially in today's technological environment, is that you can have all this data, but if you don't know what the data means or why it's important, then the data is useless. But if we can acquire that data and work with someone like you to figure out, okay, I don't have this illness and I'm going to all these doctors, and now we can figure out exactly what is wrong or what needs to be done. And I think that's extremely powerful.
Well, and I think we found something really interesting in a mold type illness, or what we probably should call a chronic fatiguing illness or a chronic inflammatory response syndrome. CIRS.
Everyone tells me it's pronounced differently.
I don't know.
CIRS, who cares? Potato.
Exactly. But what we're finding is, for most patients, I alluded to this earlier, we find a depression in the basic metabolic systems of white blood cells. So when we do our test, we're looking at immune system gene expression. So, and we want to be careful. We don't want to say your liver, your brain, your heart, because we're only looking at your immune system.
Gotcha.
And like I said earlier, every cell is different. The immune cells have a certain set of genes that are consistently expressed there that make them different from your liver. So when we talk about the results, these results are specific to the tissue from where the specimen was gathered.
Gotcha.
So, and an example, 23andMe, they look at your genome and they look at mutations. That is in every cell in your body, the same genome.
Gotcha.
And the transcriptome, which is the output of the genome for each individual cell, that is different for every tissue. And most cells have, even 2 T lymphocytes.
Gotcha.
They're going to have slightly different transcriptomes.
Gotcha.
But all we can do is take a bunch of T lymphocytes and take the average and say, on the average, here's what's going on.
So let's take a switch track here for a second, because you brought up 23andMe, and 23andMe has been in the news recently because of the California killer, and they figured out who the California killer was because they figured out DNA from all of his cousins and whatnot from data that had been released from 23andMe and other sites. With a company like yours having this information, what is typically the policy with this information, and is privacy, important to your company? I know this is a total switch track from the medical side of this,
right.
but I think it's important.
It's very important. The federal government makes us think it's important as well, because you have to follow the federal guidelines according to HIPAA.
Oh, really?
And so you're required to every type of medical record is confidential. So there can be no exposure, no exposure of a patient's medical information to anyone other than the patient's doctor and the patient, and that's pretty much the law.
So that's the law. Your data is not going anywhere.
No.
Awesome.
There are options. Certainly, we hope people take the option to have their data de-identified. So we just remove everything about your data except your age and your gender, and we like to compile that so that we know what a disease looks like. So each person might come to their doctor and say, I have a cough, I have fatigue, I have burning eyes, I have all of these symptoms. And then they'll get a series of lab tests. And then if they decide to get the genomics test, they have all of that. That's a lot of powerful information.
True.
And when we find out, okay, this person who had terrible fatigue and terrible headaches, and we find that their home or work was very moldy, and we have all of this information, the next person that walks into that doctor's office and says, I have terrible headaches, I have terrible fatigue, we like to know how we can help the next person based on the prior person.
Gotcha.
That's important.
So an evolution of the medicine.
Evolution of medicine. If we don't do that,
goes back to that database decisions, right?
If we don't do that, everything is static. We don't progress on on helping people. So I think it's important that every patient at least consider allowing some scientific or medical personnel to use that experience to help the next person.
Gotcha. No, that's powerful. So if people wanted to have these labs done, where should they go? What should they do?
Well, they can go to Surviving Mold, and I think we have
The survivingmold.com website?
survivingmold.com website. I think
just click the Progene DX
I think
button.
click the Progene DX, and hopefully all of our information is there.
I think it is.
And having this conversation makes me think we need to have an explanation of all of what we test for and the privacy that we would adhere to with the patient's record.
Sounds like you guys need a video done.
Maybe a podcast.
I know
something.
a guy. Well, anyway, guys, that is going to do it for us today. I just want to say, Dr. Jimmy Ryan, thank you so much. I know it's really hard to take this super deep information and try to make it palatable for people who really don't understand these very finite concepts.
My pleasure.
So
I
thank
hope
you
I
very
did
much.
some good.
Yeah, you really did. You
Okay.
really did. So anyway, guys, that's going to do it for us today. Don't forget to subscribe to the show so that you can get the show downloaded directly to your phone and listen to new episodes right when they come out. Please don't forget to leave us a review, as it helps other people find out this information, and you're learning just how powerful this information can be. That's going to do it for us today, and you're watching the Surviving Mold podcast.